Now we know how to calculate amount of a product, but do you get what you really calculate? In other words, if I ask you, suppose you plan to study 3 hours this evening, and then something comes up, and you end up studying 1.5 hours. Is it fair to say you really didn't study 100% of your expectation? You did not meet 100% of expectation. You really met 50% of your expectation. You wanted to study 3 hours, things came up, you didn't have time to study, you studied 1.5 hours. So your yield is 50%. What you really studied is 50%. So let me give you another example. Suppose you are baking Christmas cookies and you really want to make 60 cookies. That's your thinking. That's your theory. You haven't done it yet. And then you get the stuff, you bake them. Some of them end up burning. Some of them fall on the ground. Some of them you eat while you're making them. Some of them your kids come and eat. So at the end, you didn't get what you expected theoretically, what you thought you would get. You get 48. That's number of actual number of cookies. So what is the yield percentage? To say, I wanted to have 60, I only got 48, so 48 divided by 60 times 100, that is 80%, which means you are within 80% of your expectation. You didn't get 100% of what you thought you would get. Does this make sense? Do you have any questions so far about the meaning of yield and percent yield? So in percent yield, you're comparing what you plan, what you thought, what theoretical thinking is, with what actual result is. So do I have a formula? Yes, I can give you a formula. If you want to calculate the percentage of success, the percentage of productivity, you write actual, which what you really have in hand, what you really did in action, by over what you plan to do, what you thought you would get, times 100. The same way I talked about cookies, you thought you would get 60, you write that on the bottom. You really got the actual 48, you write that on the top, times 100, because we're doing percent, per 100. You get 80%. That means out of every 100 cookies, 20 of them were somehow gone, were lost by whatever the reason was. So in chemistry, and baking cookies is a chemistry. In chemical experiment, we never get 100% yield. Because it's real, it's experiment. It's not theoretical life, it's experimental life. So if an industry is producing certain antibiotic, and the calculation shows that you're supposed to make, let's say, 1,000 kilograms, or 2,000 pounds per hour. That really does not happen. You're going to get less than that, and then you need to get the yield. The yield may be 90% or 80%. Then the engineers and scientists sit down together and say, what can we do to increase the yield to 100%, which is theoretical calculation is meeting the actual practical work. Does this make sense? Anybody has any question about this? Any questions? Anybody? All right. So let's do this reaction. It says, without proper ventilation, you have a limited amount of oxygen. The reaction of carbon with oxygen results to carbon monoxide, a killer gas. That's why you don't do barbecue indoors. You do them outdoor to have enough oxygen not to get carbon monoxide. Now we want to understand, we want to do a problem on this example. It says, what is percent yield of this reaction? If you have produced 40 grams of carbon monoxide from 30 grams of oxygen, and we are suppose this problem is assuming there is enough. There is enough carbon. You don't have shortage of carbon. Suppose you have excess carbon. So in calculating the yield, I need experimental and theoretical. What is experimental is telling? You get 40 grams. This is experimental. This is actual. What is theoretical expectation is times 100. We already have actual. All I have to do, get the theoretical. How do you get theoretical? Well, theoretical is based on calculation. The calculations that you just learned. You go from grams of oxygen to moles of oxygen again. From moles of oxygen, you go to moles of CO. From moles of CO, you go to grams of CO. Once you have that, that is based on calculation, that's your theoretical. And then multiply the ratio by 100. If I'm going too fast, let me know. Do you have any questions so far? All right. So we are given grams of oxygen. I want to go from grams of oxygen to moles of oxygen. You need a unit conversion factor to write grams of oxygen on the bottom. You're converting into the mole, write moles of oxygen on the top. And then relate top to bottom. 1 mole of oxygen is 32 grams. And next, you want to go from moles of oxygen to moles of CO. So I write moles of oxygen on the bottom to be canceled with moles of oxygen on the top. And I want to convert to moles of carbon monoxide. And that is the ratio. If you look at the equation, what is the ratio between number of moles of carbon monoxide and moles of oxygen? Look here, 1 mole of oxygen. If there is no number here, means 1. 1 mole of oxygen produces 2 moles of carbon monoxide. So if you double number of moles of oxygen, you get number of moles of CO. So I'm going to go back. I write the ratio between these two. 1 mole of oxygen is producing 2 moles of carbon monoxide, 2 moles of CO. Next, once you have moles of product, you want to go to grams of product. So you write moles of the product, so these two can cancel each other. You write grams of carbon monoxide on the top, and the molar mass is 28 grams. Why? Carbon is 12 grams per mole. Oxygen is 16 grams per mole. You add them together, you get 28 grams. So every mole of CO is 28 grams. Now I can cancel moles and moles. I'll have grams of CO. That's what we wanted to do for theoretical part. So theory is based on calculation. And our formula said, once you have the theoretical amount, which is obtained by calculation, write that on the bottom. That's the maximum expectation. That's 100% yield. And then write what actual experimental results are on the top. Divide them together times 100. They yield the amount of the productivity is 76.2% of your expectation, of your calculated amount, of your theoretical amount. Do I make any sense? Do you have any question, anybody? Next. So in this experiment, we are giving you grams of hydrogen. So we give you grams of hydrogen and excess nitrogen. So don't worry about amount of nitrogen. You have as much as needed. And 16 grams of NH3 actual is 16 grams. What is the percent yield? Do I need to get the theoretical amount? How do I get theoretical amount? Calculation, right? Calculated amount of NH3 divided by actual. This is the actual. And then I have to multiply this by 100 to get percent per 100. So is this the formula for yield? That means I have to start with grams of NH3. Is it 16 grams? And I have to go to moles of NH3. And then I convert moles of NH3 to moles of H2. I beg your pardon. It's the other way around. Because the amount given by problem is 5 grams of H2. So I convert this to moles of H2. Then there is a relationship between number of moles of H2 and number of moles of ammonia. See, every 3 moles of hydrogen is producing 2 moles of ammonia. So I can convert this to moles of NH3. And then once I have moles of NH3, I'll have grams of NH3. And this would be theoretical. Which means it's the calculated amount. It's based on calculation. And this grams of NH3 based on calculation goes on the bottom. I have the actual 16 grams on top, and then I can calculate the percent yield. Do you have any questions so far? Anybody? So let me go to next slide. So we start with grams of hydrogen. I want to cancel grams. I write grams of hydrogen on the bottom, and I would like to go to moles of hydrogen. I write that on the top. Relate top to bottom. Can I say every mole of H2 is 2 grams because every hydrogen atom has a molar mass of 1 gram. 1 gram per mole. Each hydrogen, 2 hydrogens, 2 grams per mole. So now I have moles of hydrogen, and I want to cancel moles of hydrogen. Go to moles of NH3. So I write moles of H2 on the bottom, moles of NH3 on top, and then relate top to bottom. Every 2 moles of NH3 can be produced from 3 moles of H2. So this 3 is coming from the balancing coefficient. This 2 is coming from balancing coefficient. Next, I want to cancel moles of NH3. Go to grams of NH3. I write grams of NH3 on the bottom, on the top, moles on the bottom. And then 1 mole of NH3 is how many grams? Well, add molar masses together. Molar mass of nitrogen, 14 gram per mole, hydrogen, 1 gram per mole, 3 hydrogens, 3 gram per mole, 3 plus 14, 17 grams. So by this, calculation is telling you you should get 28 grams of NH3. And of course, calculation is theoretical, right? It's not based on running experiment, getting the product, measuring amount of product. So according to this experiment, they went to the lab, they followed experimental procedure, they ended up with 16 grams. That's the actual. So actual, which is based on experimental, on the top. 28 gram is based on calculation, theoretical. So experimental over calculated amount times 100, it says the yield of this reaction was 50%.